Good day and welcome to Lightning EV Talk, Lightning E-Motors podcast on all things commercial electric vehicles. My name is Nick Bettis. I'm the Director of Marketing and Sales Operations here at Lightning E-Motors, and I'm joined today by Brandon McNeil, our Vice President of Lightning Energy and Insights. How are you doing today, Brandon?
Excellent. Thank you, Nick.
Great. So a little bit about why we do this podcast. Lightning EV Talk is a forum for us to bring together internal and external thought leaders on all the things that can impact a fleet's ability to deploy electric vehicles. So everything from business aspects of what it means and the costs associated with deploying electric vehicles, all the way through the technical aspects and what to expect from range and telematics and all things technical. So today is another episode in our series on the fleet electrification equation. And this is an equation that we've come up with here at Lightning E-Motors to describe all of the variables associated with a successful commercial EV deployment. And those variables are selecting the right vehicles, selecting the right charging infrastructure and deploying that effectively, service and maintenance, financing, telematics software, and of course grants and funding to support all of that. So today we're going to be talking specifically about infrastructure and charging with Brandon. So let's get into our content today. So Brandon, let's start off with just a high-level view of why charging equipment infrastructure seems so complex to fleets.
Sure. Well, I think, when you look at how fleets operate today, right, they're used to going out and purchasing the same vehicle that they've bought from the same OEM, in many cases for decades, and then hiring a driver, handing a fuel card to that driver, and really being done with the upfront planning aspect of it. So, now today when both we specifically as Lightning, but I think even more importantly, we as a broader community are asking fleets to electrify. They're now needing to enter into this whole new planning and execution process that hasn't been required before when they were working with internal combustion vehicles. And so it's a meaningful lift now for a fleet to first of all make sure that they've selected and found the right mix of available commercial EVs that are going to fit for their application. But now they're taking on responsibility for fueling their own vehicles. And that's what we'll talk about in detail today. But that's a meaningful additional effort that we're asking the fleets to undertake.
It's a step for sure. Mm-hmm. So let's start with the basics here. So let's talk about charging stations. Mm-hmm. There are a lot of different types of charging stations. So maybe just a high-level view of whether the various types of charging stations, their various levels, and maybe how those apply to a fleet.
Yeah, certainly. So charging stations can range from very inexpensive, relatively slow, what are referred to as level 2 charging stations, up to very fast, very expensive DC fast charging stations, which could be several hundred kilowatts or more as we move into the future. Charge rates just continue to increase. So as a fleet, that's one of the first considerations you need to make. You need to understand, what vehicles am I buying? What's the application that I'm deploying them in? And based upon that, what's the best mix of hardware solutions from a charging standpoint to ensure that my vehicles can be charged appropriately, but is also done at the slowest charging rate possible? Because as you go up in charge rates and you switch from level 2 to level 3, the expense just increases. So, the general rule of thumb is you want to be able to charge with the slowest equipment possible to meet your necessary charging demand. Okay.
And from a wear and tear on the battery perspective, is a slower charge better for the battery than a higher charge? And if so, what's the difference there? Mm-hmm.
Yeah, it certainly is more healthy for the battery to charge at a slower rate. Same thing with your phone. A fast charge is nice, but if you do that consistently every day or multiple times a day, it's going to wear down the battery life. That's another aspect of the rule of thumb, that you want to identify kind of the slowest charge rate possible to get the job done. It's healthier for the battery. It's lower upfront cost, both in terms of the hardware and the install. And then it's also lower ongoing cost because it's going to have lower impact on demand charges.
Right. Gotcha. All right, great. So you also mentioned matching the chargers to the specific use cases. So when you're working with fleets to map out their charging plan or their charging strategy, how do you go about looking at routes, looking at variable routes across the fleet, and matching the charging infrastructure to those routes and for that fleet?
Yeah, that I think highlights what is the first and I believe most important aspect of infrastructure, and that's planning. Upfront planning is absolutely critical when you're looking at electrifying even just a couple vehicles up to a large percentage or a full depot or even multiple depots. It starts with identifying the size and type of vehicle that you're going to be deploying, how many of those vehicles are going to be deployed at a specific location, and then based upon that, looking at route demands, dwell time that's available each evening for the vehicles to recharge. If the dwell time's insufficient to recharge the vehicle, or if the vehicle range is short enough that you can't quite complete a full route on a single charge, then you also need to evaluate what we call opportunity charging, which is periods of time in the midst of a route where you may be able to stop and do some fast charging. So that could be over lunch, over breaks, driver changes. So all of that needs to be evaluated to determine the right mix of charging hardware that can be deployed at the location to support those vehicles. And then the next critical aspect of planning is, once you know the right mix of vehicles and hardware, is can the site itself support that implementation from an electrical capacity standpoint. And if the answer is yes, great. You go about your engineering and it becomes a construction project at that point. If the answer is no, then there's a number of additional things to consider, whether that's utility upgrades, bringing in on-site generation resources, effectively creating a microgrid within your depot, or other strategies.
Yeah. So that's a frequent question I get, and part of the challenge for fleets and the complexity of this whole thing is, all right, now I had to figure out my vehicles, and now I got to figure out what charging I need, and now I got to go work with the utilities. What resources have you seen? I know we help with that, but are there other resources in addition to maybe explaining how we can help fleets with that whole ecosystem there?
Certainly, yeah. There's a couple of terms that are commonly being thrown around in the industry right now, which are both kind of as a service approaches. One is charging as a service. Another one is you'll hear a few different ways of describing it as either transportation as a service, vehicle as a service, EV as a service, et cetera, where one or more entities work together with a finance partner to deliver a fully managed turnkey solution to the customer. That could be, in the case of charging as a service, would be a scenario where if the fleet is operating a depot, a third party would come in and get licensed to or lease the physical space on the property, and then deploy charging as a service to that fleet, where they would purchase, install, own, and maintain that charging infrastructure on behalf of the fleet, and the fleet would just pay on a per month or per kilowatt hour basis for the use of that infrastructure. And then extending that to include the vehicle, which we would describe as EV as a service, really just now rolls the vehicles that are being deployed as well into that financing mechanism. And in that scenario, you may price it on a per mile basis or on a per month basis. But yeah, that's certainly a way to simplify the overall process for the end user, and is a key aspect of the strategy that we at Lightning are developing, because we do see that this whole fleet electrification equation that a fleet needs to engage with and solve can be a meaningful lift. So if we can come in and solve that equation on their behalf with the right mix of partners and financing, then that allows fleets to scale much more quickly.
Yeah, and that's really the equation is, as I mentioned before, we're talking about vehicles, charging, telematics, service, all those things. And that's really the direction I think we'd like to go, and we want to help the fleets deploy quickly with, is by being able to provide all of that including the telematics software, the service and support maintenance and all that sort of thing, all in one package. So
Exactly.
all right. So if there is not enough power coming into the site, and utility is not infrequently saying that's going to be 12, 18 months before we can get to that, what other options does a fleet have to actually deploy a fleet more quickly and while waiting for that to get done?
Yep. Yeah. So this is an issue that we've seen commonly as we've worked with fleets. Usually when you're deploying an initial trial, like a 1 to 10 unit initial deployment, you can usually kind of wind your way through the electrical challenges on site and figure it out. Yeah. But once you want to deploy at scale at a specific depot, you'll almost always run into some sort of electrical constraint unless the site has been specifically built with EV charging in mind. So the first consideration, like you mentioned, is, all right, can we work with the utility to bring in additional capacity? That's certainly the simplest solution. But oftentimes that can take 1 to 2 years. And in some scenarios, the utility will cover that cost. In others, you may need to bear some of that cost. So it may not be a cost-effective approach, and it certainly may not fit the fleet's timetable. Right. So if that's not an option, or if we need a stopgap while we wait for that to be deployed, you can also look at essentially becoming your own utility, with a combination of on-site generation and energy storage. You may be able to deploy solar, small wind, and other types of clean generation that would allow you to generate the electricity that you would need on site to cover that gap. And then we also offer a product that's a battery-based mobile charger that can take a relatively small level 2 feed from the grid or really any other AC source, and use that to charge the batteries on the system, and then we can discharge from that to one or more vehicles. So we certainly see that as being a useful stopgap. For instance, if we're working with a potential customer and our infrastructure partner says, okay, we can have the permanent infrastructure installed with the proper electrical feed in 12 months, but at Lightning, we can deliver the vehicles in 3. What are we going to do with that 9-month gap? This mobile charger, we believe, could be a great solution in that scenario, where it's deployed on kind of a lease basis for that 9-month period. It's able to be charged with the available electrical capacity on site, and it enables that fleet electric deployment much more quickly.
Right. So you just tow that to somewhere else on the campus, plug it in during downtimes, and then bring it back and discharge it DC.
Yep.
All the vehicles are.
Yeah, it could be located, semi-permanently on the campus with, just a smaller electrical feed to the system, or it could be something, where you charge it off campus and bring it on periodically. There's a number of different ways to approach it, and we can certainly work alongside customers to help figure out the best approach.
Okay. So pursuant to the microgrid idea, if you're going to put solar or small wind or other aspects to generate your own power, that brings up the question of vehicle to grid then. So you're charging these vehicles with your own power. A good example of this is VA in Boulder, which has got one of our electric transit buses, and they have their own microgrid. Can they then use the power storage on that vehicle to feed it back into the grid and actually regain some of the funds that they would have spent normally?
That's certainly the direction that the industry is going. There's some work that still needs to be done collectively as an industry to fully get there. The standards are still being finalized at this point, but absolutely is the answer long term. May be difficult to pull that off in the next 6 months, but in the next 1 to 3 years, Absolutely, we'll be there as an industry where the vehicle itself or collection of vehicles can certainly be a resource to the building or depot that they're connected to, but then also may become a resource to the broader grid. And there's of course, the requirements that the vehicle be equipped with the right hardware and software to enable that. The charging station that you're connecting the vehicle to needs to be properly equipped. And then you need the right pricing and tracking mechanisms in place with the electric utility so that they can measure how much electricity you're feeding back into the grid and compensate you appropriately for that. So yeah, I certainly see, especially with vehicle classes that tend to be stationary in the late afternoon, early evening, where the grid is most stressed, in particular in the summer, of which school buses are an obvious fit. I see vehicle to grid taking off and having a meaningful impact in those areas. And there's even been talk. I was at a conference recently where they were proposing that in the right scenarios, and I think again school buses could be ideal for this. The utility may actually be able to treat those as capitalized assets and help cover some of the costs of the vehicle because now it becomes an extension of their grid and
that's great.
Their resource capacities.
Yeah, what school district couldn't use a little extra funds coming in, right?
Yeah, no kidding.
Right.
Yeah.
So let's talk about the actual pricing structure for utilities. In most places now there's a tiered pricing structure. How does that impact the planning process for fleets?
Yeah, it's certainly a meaningful consideration up front during your planning stage. You want to understand what pricing am I on today? Is there an available EV specific rate structure that I could migrate to that would be a better fit once I have the chargers and EVs deployed? But in particular, post deployment, that's where software now can play a critical role in helping ensure that you're optimizing the usage of your chargers to align with your utility rate. Because commercial utility rate structures can be pretty complicated. They charge you both in terms of the total energy that you consume and break that up into different time periods throughout the day, as well as they charge you for the maximum draw that you're taking at any given moment. And if you hit that during certain periods of the day, that can penalize you just for one bad day.
Oh.
So on the right rate structure, if all the drivers happen to show up at the same time and plug in at the same time, and so you set a really high draw for 15 minutes, that could set your entire bill for the month. There's we offer software that helps to control this. There's other players in the market that do as well. But ideally, you identify the state of charge of the vehicles coming back at night. You know the job that those vehicles are scheduled to do the next day. And then based upon that, you come up with an optimized charging strategy that leverages the time of use rates to make sure that the majority of charging is occurring when it's cheapest, while also making sure that each vehicle is properly equipped to do the job the next day.
Right. So it sounds incredibly complex, but it sounds like the software tools are there to simplify this and really almost make it a no-brainer for most operators.
Yep. Yeah, exactly.
Great. So let's just wrap things up and give our listeners today the single best piece of advice you could give them as far as charging infrastructure for an electric fleet deployment.
Think charging first. I know that may sound counterintuitive coming from a vehicle OEM, but we've seen it happen the other way around so many times where our customers have thought vehicle first, purchased the vehicle, and then realized too late in the process that they had started planning the infrastructure far too late. And so we end up with vehicles being delivered, chargers not being ready, or there being a mismatch between the vehicle, the charger, and the desired application that the vehicle is going to be operating in. So as early in the process as possible, really as soon as you've defined the type and number of vehicles you're going to be deploying at a location, figure out how you're going to charge it. And don't be afraid to ask for help in that process, right? We've formed our our own dedicated energy division here at Lightning that is specifically here to help fleets answer these questions and come up with the right strategy that works for them. Be ready and willing to ask for help and plan early and often.
Yeah, I think if I look back at the deployments we've had in my time here, almost universally the ones that have had a slower success rate have become because the charging infrastructure was not either matched, as you mentioned, or in place by the time the vehicles arrived.
Right.
So that's key. That's definitely item number one. So.
Certainly.
Well, great. Thank you, Brandon, for today. And thank you, everybody, for listening. Again, this is only one component of the fleet electrification equation, one variable, if you will. We have podcasts on all 6 variables on our site, so please check out those when you have a chance. And we hope to see you next time on Lightning EV Talk.